All right, everyone, let's talk about earthquake magnitude. Earthquake magnitude involves the strength of the earthquake, and there's really two ways to measure it. Uh, we looked at the seismic waves and how they produce a shaking in the earth, and the seismometer measures the shaking, and the seismogram records the shaking. We can use a record of the shaking in order to determine how strong the earthquake is through magnitude. The other way to measure strength of an earthquake is through intensity. And this is through the amount of damage the earthquake does. And so we're going to talk about both of these here today in our discussion on earthquake strength. First off, the Richter scale. The Richter scale is kind of the most famous and first measure of earthquake magnitude using a seismogram. It was developed by Charles Richter in the 1940s, who was out of the University of California, Berkeley. And those California earthquakes, they responded well and were well described by the Richter scale. They are shallow earthquakes that are kind of small to moderate in intensity. And what Mr. Richter found was that if you use the seismogram and the seismogram heights, particularly when you look at the surface waves and compare them with the P and the S waves, you can actually rate the magnitude of an earthquake. And essentially, what magnitude is the amount of energy released by the earthquake. And so he came up with a scale. It's a numeric scale from 0 to question mark. The highest recorded earthquake in history was a 9.5 in Chile in 1960. Um, and of course, we get very little earthquakes constantly because of the plate motions that are constantly at work. But every increase of 1 on the magnitude scale for the Richter scale is an increase of 31 times in energy release. So what that means is like a 6 magnitude earthquake is like 31 5 magnitude earthquakes put together. The energy released in a 6 magnitude earthquake is the same as 35 5 magnitude earthquakes. I'm sorry, 31 5 magnitude earthquakes. So as you can see, as you get higher in the scale, it gets really, really, really big, and the amount of energy released by the earthquake. Now, what they found was that the Richter scale was actually not super accurate for deeper earthquakes or earthquakes that were stronger. And so what they did was they modified the magnitude calculation and found that they could do so using what they call moment magnitude. And moment magnitude is, or seismic moment, measures the actual shaking by the earthquake, but it also takes into account the rock type, the amount of fault that slipped, and how far it slipped to determine the magnitude. And when they put all these together, they can get really accurate measurements for these earthquakes that are 8 plus magnitude or those that are deeper. You can see my scale on the right here showing the number of earthquakes per year worldwide, and you can see there are many, many earthquakes that are under a 2 magnitude, and those are pretty low in the amount of energy released. As you start to move up the scale, there are less and less of these earthquakes, noting that a 3 plus magnitude earthquake is like a large lightning bolt in energy release. An average tornado would be like a 4 or a little almost under a 5 on the magnitude scale and the amount of energy released. And then you go up here and it lists different earthquakes. The one that occurred in Northridge, California in 1994 was a pretty damaging one in the LA area. And that was just a little bit stronger than what they would have experienced on the surface above Hiroshima when they released the atomic bomb there in World War II. So, to give you an idea, a 6 magnitude earthquake is no joke. Um, and that's the amount of energy that's pulsating through the Earth's crust. The Loma Prieto earthquake in California in 1989 was also called the World Series earthquake because it occurred during one of the games of the World Series. Just over a 7 magnitude there, very, very strong. Again, that would be like 31 Hiroshima bombs put together. You've got Mount St. Helens eruption, just under an 8 magnitude earthquake in energy release. The world's largest nuclear test here in Russia would be over an 8 magnitude earthquake. And then the largest earthquake in recorded history there, Chile 1960, and a 9.5, one of the largest earthquakes, and a lot of energy released there. Here's a little look at each of these magnitudes just to give you an idea. The Hiroshima bomb at 6.0 magnitude, about 0.15 megatons of energy. 6.9 in Loma Prieta. This was the World Series earthquake I described earlier. Then we have the Haitian earthquake of 2010. This was a 7 magnitude earthquake, which is equivalent to about almost zero point 0.5 megatons in energy release. We've got the San Francisco earthquake of 1906 at an 8 magnitude earthquake. This was a very significant earthquake, and believe it or not, most of the damage from this earthquake was done by fire. We'll kind of touch on that a little bit more later, but when we talk about earthquake damage, but fire is a significant hazard when it comes to earthquakes. And here's a comparison there, the largest ever atomic bomb, the Tsar Bomb at 8.35 magnitude release of energy. And the Japanese earthquake of 2011 at a 9.0 magnitude at 480 megatons was enough energy to release a tsunami that really rocked the coastlines of Japan. In 1964, the Alaskan earthquake at 9.2 magnitude at 950 megatons, and over 1,000 megatons would be the largest earthquake in the Chilean earthquake. Actually, probably one of the larger events on Earth would be impacts with space objects. Some of the large impacts that created the Earth and even helped to create the moon would have been so massive that they fractured the Earth itself. This one, the Chicxulub impact, would have occurred in 65 million years ago. This would have been about the time the dinosaurs went extinct, and scientists think that this impact was the cause for that. This would have been equivalent to a 13 magnitude earthquake. That would be like the largest earthquake we've ever had, 120 of those put together to make this impact and the magnitude it would have reached on Earth. Probably one of the larger energy release events in the universe would be an Earth starquake, a quake from a Magnetar, very, very dense star, would be a 23 magnitude. This would be more energy than the sun emits in 150,000 years. And the sun is a nuclear fusion reactor, so that'll give you an idea of how much energy is released here. All right, so that's magnitude. That's the strength of an earthquake as measured by the energy released. When we measure the strength of an earthquake by the damage done, this is what we call intensity. So let's discuss intensity.
The intensity is measured, it basically measures the damage done by an earthquake and what was felt by an earthquake. And Mercalli scale was developed to measure this. It's a Roman numeral scale from 1 to 12. And it was developed by Giuseppe Mercalli in Italy in 1902. A lot of earthquakes over there as well. What they do is scientists will survey the damage done by the earthquake and also ask what people felt and assign it a Mercalli rating. For example, a 1 on the Mercalli scale is not felt by anyone. A 5 on the Mercalli scale would be felt by all, some minor damages. A 10 on the Mercalli scale is well-built structures being destroyed. And a 12 would be waves seen moving on the ground and objects being thrown up into the air with total damage. The good thing about the Mercalli scale is that when you pair the Mercalli scale today with the Richter scale, you can get not the Richter scale in general, but just a magnitude scale in general. You can estimate the magnitude of past earthquakes back before we had any seismic data. So today we have good data on the magnitude of earthquakes given by the seismograms and the slippage along the faults and so forth. Back in the day, back beyond say the 1940s, we really didn't have any kind of seismograms or seismic data. And so being able to pair this Mercalli scale ratings with actual magnitude readouts, we can actually determine or kind of estimate what magnitude the earthquakes were in the past. Seismic intensity maps are drawn up by what the Mercalli rating is at each location nearest the epicenter. You can see pictured here a seismic intensity map of the 1886 Charleston, South Carolina earthquake. And in this one, you can see that the highest of the shaking felt was near the coastline, and then it kind of radiates out in a bullseye pattern from there. This earthquake could be felt all the way through the south and east portion of the country, all the way through Ohio and parts of Indiana. And then it got started getting lighter after that. But even Chicago could feel this earthquake. So this is the power in creating a seismic intensity map and looking at seismic intensity or the Mercalli scale rating.